You are in civil and architectural engineering. So where should we start?
Let's start at the very beginning.
All right, we'll start with the history of civil engineering and architecture. So if you have your guided notes out, a couple of the first two questions ask for the definitions of civil engineering and for architecture. So go ahead and pause this and type those out. Did you pause it? You should. All right, good for you. So, definition of civil engineering is an engineer trained in the design and construction of public works, dams, bridges, other things, architecture's art and science of designing building for human habitation. Civil is the oldest branch of engineering. In general, engineers were used for military purposes. The term civil was added to separate them from other engineers who worked on military or other mechanical type projects, things like that. Architects are licensed professionals who design commercial and residential structures that are used by humans. So civil engineering, some of these things, bridges, dams, may not necessarily be habitation type things. So that's kind of your big distinguishing characteristic. Architects design things for human habitation. So architecture was born when people began to live in dwellings within communities. Caves were last used as habitats around 8,000 BC, long time ago, and early engineering was centered around food. The development of tools and ways to increase efficiency of farming, things like that, farming techniques, hunting, was documented first in cave paintings and later in Egypt in little hieroglyphic-y things. And that's when people started needing places to live, and so there we have architects. Building materials were chosen based on availability and climate. So in Greece, what do you think they used by looking at this? Say it in your head. Yeah, maybe marble, things like that, stone. That's what they had around them. What did Machu Picchu use? So if this is built on a mountainside, they probably used the stone that was cut out of here. And they actually had dry cut stones. They dry cut them, meaning they didn't have mortar or dirt or mud or anything like that, mostly because it's mostly rock. And so they would just dry cut and perfectly fit them together right next to each other. How about the ruins of Babylon, present-day Iraq? What do you think? It's built on an alluvial plain, which means there's no wood, there's no stone. It's all sun-dried bricks and things like that and clay that they use, because the alluvial fan, that was kind of where water sort of drained out. So it's mostly clay. How about the Chinese? Here's your hint. They use mostly wood, but since wood rots away, we actually don't have any historical buildings about the Chinese, but we do have some historical drawings that they used, and they didn't really change some of their designs very much at all. So not a whole lot has changed, so that's how we know that they built largely out of wood. And one more. How about the Smurfs? If you said mushrooms, you're correct. Vernacular architecture is a method of construction that uses locally available resources and traditions to address local needs. So vernacular architecture is basically just using what is locally available. And some people think it's kind of a crude way of architecture, just using what's there. But some architects get inspiration from some of these vernacular buildings. Here's a couple. Here's an Apache one built with grasses. Nepalese house, stone and clay, that's what they have available. In Africa, they have this stone one. Here's a southern Africa. Even in the plains in America, all they had was just sod, just grass. There was no forests around. We planted a lot of the trees in the Great Plains. So they would just cut sod blocks out and stack them on top of each other, and then boom, you have a house made out of grass or sod and dirt. The earliest really large structures were these pyramids. They were built as tombs for some of the pharaohs, and the earliest known architect was Imhotep of Egypt. I got a chance to go there. I did not meet Imhotep because he's been dead a long time. He was known for creating the pyramid at Saqqara around 2700 BC, so a long time ago. These are just solid structures. They also built these bearing walls. So to build really tall walls, you can't just build one wall. You have to build another wall, and they kind of interlock, and then neither wall can fall over. because they're sort of interlocked. So if you ever built with Legos, you know you have to interlock pieces kind of every other row. So that's sort of what they're doing. They're binding these bearing walls together, and then they're really, really strong. They provide support for each other and for a roof if they can figure out a way to make a roof in there. But there was problems with roofs. Not a lot of rain in Egypt, so there are a lot of buildings that don't even have roofs in Egypt. The Egyptians were not the only ones who built pyramids. This one is in the Americas. It's the Kukulkan's pyramid, and it was in Yucatan, Mexico for astronomical purposes. It wasn't built as a tomb, but just for to look at the stars and study the stars and things like that. Here's some modern pyramids. So why the heck do we build modern pyramids right now? We have telescopes, we have cemeteries, so we're not putting dead people in these things anymore. They are built for aesthetic reasons because they look really, really cool. So this is the Louvre in France, and there's a museum that's actually underneath here. This is the skylight that you can look up above. It's very, very cool. So that word aesthetics is when you would design something just because you think it looks pretty, or it's neat, or it's pretty neat.
That's pretty neat.
The Parthenon was built to house a statue of Athena, the Greek goddess of war. And it's an example of post and lintel. So you can see these are the posts, these tall columns, and the lintel is this horizontal member here, this stone thing. This form of construction came about due to an early problem in architecture. So right now you should probably be on question number 8. And that's how can a door and window opening be provided in bearing walls without sacrificing support. So they figured out if you make these posts, you can make openings up to a certain length. If you go any longer, any wider, then the stone may crack on the bottom here because it's bowing down with all that weight. And stones don't like to be ripped apart. And the bottom, if it starts to bow down, the bottom is getting ripped apart and the top is getting compressed. Compression on stone is not a problem. But if you start bowing this bottom part down, it's under tension and it will start cracking. And once the bottom cracks, that crack runs all the way up, and then that whole thing falls down. So they figured out how thick you had to make the stone to be able to go from across this gap, probably mostly through trial and error. And they figured out this way is pretty safe, at least these people hope so. So this is an example of an early frame system, and that's what they did to try to bridge this gap right here. But then the Romans came around and they figured out, you know what, there's got to be a better way. So they started developing these arches. And an arch is just a sequence of these stones. Typically these are trapezoidal stones, but not necessarily. They don't always have to be. And the top of these is a keystone. So you can see this one. This one is a really pretty one. These are more ancient type arches. This keystone, as it gets pushed down, then those forces go out because that stone can't go down anymore because there's other stones that are kind of locking it in place. So this one goes down, those forces go out, that next force goes out and down, out and down, out and down, out and down, all the way down to the bottom. It's pushing out this direction, but this arch is pushing back onto this direction, so they kind of hold each other up. So the arches were designed because the Romans decided, hey, we want to bridge even larger gaps, and they can do that by making these really large arches. So essentially the arch overcomes the limitations of that post and lintel, and that makes the Romans really smart. These stones here are called voussoirs, and the keystone, again, that's something you got to make sure you note, is always at the crown. It's always at the top of the arch. So what are some other modern examples that use arches? Think. Like St. Louis Arch, for example, that could be one. You also see them as continuous arches that just continue on forever, and those things are not forever, but those things are called vaults. So an arch that continues is a vault, like a highway tunnel would be a good example of a vault. A cross vault is where you have two of these that intersect, and it's the same principle. You still have all the weight on the top, and then that sort of spreads out to the sides. And once we get kind of to this vertical piece, we don't have any more side load. It's all going down. Domes are simply arches that have been rotated. So that is a dome. We're looking straight up at the dome. What are some other domes that are used in modern architecture? Yes, the Capitol, that's a good one.